Good morning students, I am Ashmi Prasad and creator of this channel Digital Generation. This channel is regarding chapter wise preparation for both ISSC and CBSE students. I hope you will get best knowledge and explanation from this channel. After acids, today we are going to study about bases. The solution of substances of caustic soda, lime and washing soda gives bitter taste and they are soapy or slippery to touch. So we can say that bases are those chemical substances which have bitter taste and are soapy or slippery to touch. Bases are chemicals opposite to that of the acids. So when bases react with acids, they neutralizes acids. Thus, we can say that bases are those chemical substances which reacts with acid and neutralizes the acids. So, metal oxides and metal hydroxide is a base. Metal oxides like sodium oxide or calcium oxide and metal hydroxide like sodium hydroxide and calcium hydroxide, ammonium hydroxide which is not a metal hydroxide but still ammonium hydroxide is a base. All bases turns red litmus blue. Metal carbonates and metal hydrogen carbonate like sodium carbonate and sodium hydrogen carbonate react with acid and neutralizes the acid. For example, sodium carbonate and calcium carbonate, they react with acid and neutralizes the acid, and metal hydrogen carbonate like sodium hydrogen carbonate also reacts with acid and neutralizes the acid. Thus, overall we can say that all metal oxides, metal hydroxides, metal carbonates and metal hydrogen carbonates are bases because they neutralizes the acids. Now, what are alkalis? Water soluble bases are known as alkalis. Most of the bases are not soluble in water, but some of the bases like sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide and ammonium hydroxides are soluble in water. So, water soluble bases are known as alkalis. Water soluble bases are useful to us than insoluble bases because all the reaction of bases takes place in aqueous solution. So, here in our discussion, whenever we will mention base, we mean water soluble base or alkali. So, if we write base or alkali, it means the same because we are here considering only the water soluble bases. What do all the bases have in common? When bases are dissolved in water, then they produces hydroxide ion. So, we can say bases are those chemical substances when dissolved in water produces hydroxide ion. For example, when sodium hydroxide is dissolved in water, it dissociates to give sodium ion plus hydroxide ion. And the presence of this hydroxide ion in base is responsible for its basic characteristics. All other bases like potassium hydroxide, calcium hydroxide, magnesium hydroxide and ammonium hydroxides, they all produces hydroxide ion. And these hydroxide ion imparts the basic property to all the bases. One thing must be clear here that when we dilute bases, then we add water to it, and by adding water to bases, the concentration of hydroxide ion decreases by unit volume. So, by diluting acid, concentration of hydroxide ion decreases by unit volume in bases. So, here we can see that whenever base is dissolved in water, they produce hydroxide ion and a metallic ion. Similarly, in the case of calcium hydroxide, when dissolved in water, it also gives calcium ion plus hydroxide ion. Bases are of two types, strong bases and weak bases. Strong bases are those bases which ionizes completely in water to give hydroxide ion. For example, sodium hydroxide and potassium hydroxides are strong bases. In strong bases, the concentration of hydroxide ion is more than in weak bases, and as a result, strong bases are better electrolytes than weak bases. When sodium hydroxide is dissolved in water, then it ionizes completely to give sodium ion and hydroxide ion. Weak bases are those bases which are partially ionized in water, and the concentration of hydroxide ion in weak bases is very small. So weak bases are not good electrolyte as that of the strong bases. Weak bases are calcium hydroxide, magnesium hydroxide and ammonium hydroxide. These are the examples of weak bases. Now we will study about the properties of bases. We have already studied the physical properties of bases. Bases have bitter taste. Bases are soapy or slippery to touch. Bases dance red litmus blue, and the bases are good electrolytes because when bases are dissolved in water, they produces hydroxide ion. Now we will study the chemical properties of bases. Bases reacts with some metal like zinc and aluminium and produces salt and hydrogen gas. Bases do not react with all metals, but bases reacts only with zinc and aluminium. For example, when sodium hydroxide reacts with zinc granules and it is heated, then it gives a salt called sodium zincate plus hydrogen gas. This is a salt. In this salt, sodium zincate, the metal zinc is present as negative ion or anion. It is present in the form 2Na plus ZnO2 2 minus. So we can see that zinc is present in the form of negative ion. Similarly, sodium hydroxide also reacts with aluminium and form sodium aluminate plus hydrogen gas. If we take zinc granules and sodium hydroxide in a boiling test tube and heat it, and then we pass the gas which is liberated through soap solution via delivery tube, then we will see that air bubbles are coming out from soap solutions. And if we bring a glowing splinter near these air bubbles, then this glowing splinter burns with a pop sound. So we can say that the gas produced during reaction is hydrogen gas because pop sound is a confirmatory trace for hydrogen gas. Number 2, when bases reacts with acids, then they produces salt plus water. The reaction between bases and acid is actual neutralization reaction because the hydrogen ion produced by acids and the hydroxide ions produced by bases reacts with each other and neutralizes each other and forms water. Let's see the reaction. When sodium hydroxide reacts with acid, then it forms sodium chloride, a salt, plus H2O. Again we can take when potassium hydroxide, a base, when reacts with sulfuric acid, then also it forms a salt, potassium sulfate plus water. This is the actual neutralization reaction because in this reaction of bases plus acid to form salt plus water, here acid produces hydrogen ion and bases produces hydroxide ion, and they neutralizes each other to form water. Number 3, bases reacts with non-metallic oxide to form salt plus water. Let's take an example. When a base calcium hydroxide reacts with non-metallic oxide carbon dioxide, then it forms salt plus water. Calcium hydroxide, which is called slag lime, when reacts with carbon dioxide non-metallic oxide, then it gives calcium carbonate plus water. So from this reaction we can say that non-metallic oxides are acidic in nature. One thing must be remembered, that when acid reacts with metallic oxide, then also it produces salt plus water. So acid reacts with metallic oxide and bases reacts with non-metallic oxide. So metallic oxides are basic in nature and non-metallic oxides are acidic in nature. When hydrochloric acid is reacting with zinc oxide is metallic oxide, then it gives salt zinc chloride plus water. So zinc oxide or metallic oxide is basic in nature. because acid plus base reacts to give salt plus water. Whereas in this case, when calcium hydroxide, which is a base, reacts with carbon dioxide, then it gives salt plus water. So it is acidic in nature. Carbon dioxide or non-metallic oxide is acidic in nature. Now we will study about the uses of bases. Bases have many important uses. For example, sodium hydroxide is used as caustic soda, and sodium hydroxide is also used in paper industry, soap industry, and also in the manufacture of synthetic fiber called rayon. Sodium carbonate, a base, is used as washing soda and also for softening of water. Sodium hydrogen carbonate is used as baking soda. When sodium hydrogen carbonate or baking soda is mixed with tartaric powder, then it forms baking powder. Sodium hydrogen carbonate is also used as antacid and is used for curing of indigestion when stomach produces excess of hydrochloric acid. ENO is an example of sodium hydrogen carbonate. So when sodium hydrogen carbonate reacts with excess of hydrochloric acid produced in the stomach, then it forms salt plus water plus carbon dioxide and thus neutralizes the acid. Sodium hydrogen carbonate is also used as soda acid fire extinguisher. When sodium hydrogen carbonate reacts with sulfuric acid in soda fire extinguisher, then it produces a salt, sodium sulfate plus carbon dioxide and water are produced. This carbon dioxide and water is used for extinguishing fire. Magnesium hydroxide is also used as antacid. Magnesium hydroxide is also known as milk of magnesia and is used for curing of indigestion when stomach produces excess of hydrochloric acid. Magnesium hydroxide reacts with hydrochloric acid in stomach and produces magnesium chloride salt plus water and thus neutralizes the acid. Calcium hydroxide, which is called slack lime, when dissolved in water, then it produces calcium hydroxide solution, and this calcium hydroxide is used for whitewashing. Again, calcium hydroxide is also used for manufacture of bleaching powder. When calcium hydroxide reacts with chlorine, then it forms bleaching powder CaOCl2 plus H2O. These are the uses of bases. One thing you must be familiar with, whenever we say caustic soda, then we mean sodium hydroxide. Sodium hydroxide is known as caustic soda, and whenever we say washing soda, then we mean sodium carbonate. So sodium carbonate is known as washing soda, and baking soda, sodium hydrogen carbonate is known as baking soda. So never get confused with these three terms. Now we will discuss some related questions in this topic. Name the gas evolved when zinc granules are treated or heated with hydrochloric acid solution. When zinc granules are heated with hydrochloric acid solution, then salt zinc chloride plus hydrogen gas is evolved. So the gas is hydrogen gas. Sodium hydroxide solution. When zinc granules are treated or heated with sodium hydroxide solution, then a salt sodium zincate plus hydrogen gas is evolved. Thus in both cases, when zinc granules are treated with hydrochloric acid or when zinc granules are treated with sodium hydroxide solution, hydrogen gas is liberated. And the confirmatory test for hydrogen gas is pop sound. Next question. What is the common name of water soluble bases? Water soluble bases are known as alkalis. And examples of alkalis are sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide and ammonium hydroxide. What is common in all water soluble bases? The common in all water soluble bases is that they produce hydroxide ion when dissolved in water, meant by strong bases and weak bases. Strong bases are those bases which are completely ionized in water, and weak bases are those bases which are partially ionized in water. Strong bases are those substances which contains greater concentration of hydroxide ion, and weak bases are those bases which contains lesser concentration of hydroxide ion. Strong bases are better electrolytes than weak bases because strong bases contains greater concentration of hydroxide ion. Examples of strong bases and weak bases. Strong bases are sodium hydroxide and potassium hydroxide, and weak bases are calcium hydroxide, magnesium hydroxide and ammonium hydroxide. Classify them as strong or weak bases. So ammonium hydroxide is weak base. Sodium hydroxide is strong base. Calcium hydroxide, it is weak base. Potassium hydroxide, it is strong base. And magnesium hydroxide, it is weak base. What ions are present in the solutions of the following substances? Hydrochloric acid, here hydrogen ion is produced. Nitric acid, here also hydrogen ions are produced because all acid produces hydrogen ion when dissolved in water. Sulfuric acid also produces hydrogen ion. Sodium hydroxide produces hydroxide ion. Potassium hydroxide produces hydroxide ion because these are the bases. Magnesium hydroxide also produces hydroxide ion. Bases produces hydroxide ion, whereas acid produces hydrogen ion when dissolved in water. Differentiate between acid and base with two examples and also state two similarities between them. Difference between acid and base is that acid tastes sour whereas base tastes bitter. Acid turns blue litmus red whereas base turns red litmus blue. And two similarities between acid and bases are that acid reacts with base to form salt plus water. Bases also reacts with acid to produce salt plus water. That is, neutralization reaction takes place when acid and base reacts. And another similarity is that acid and base both are good conductors of electricity. That is, they are good electrolytes because acid contains hydrogen ion and bases contains hydroxide ion. Name two acids, sulfuric acid, hydrochloric acid, and name of two bases are sodium hydroxide, potassium hydroxide. Give the name and formula of two strong base and two weak base. Two strong base are sodium hydroxide, NaOH, and potassium hydroxide, KOH, and two weak base are calcium hydroxide, CaOH2, and magnesium hydroxide, MgOH2. What type of ions are formed when an acid is dissolved in water? When acid is dissolved in water, it produces hydrogen ion in water. When a base is dissolved in water, it produces hydroxide ion. Write the neutralization reaction between acid and base in terms of ion involved. Acid produces hydrogen ion whereas bases produces hydroxide ion. So the hydrogen ion produced by acid reacts with hydroxide ion produced by base and produces water. This is called neutralization reaction. Write any two uses of bases. Bases like sodium hydroxide is used as caustic soda. Sodium hydroxide is also used in soap and paper industry, and it is also used in manufacture of a synthetic fiber called rayon. Another base, calcium hydroxide. When calcium hydroxide is dissolved in water, then the solution of calcium hydroxide is used for whitewashing, and calcium hydroxide is also used in manufacture of bleaching powder. So two uses of bases. Sodium hydroxide is used as caustic soda, and in soap and paper industry it is also used, that is caustic soda is also used in the preparation of synthetic fiber called rayon. And another base, calcium hydroxide, is used for manufacture of bleaching powder. When calcium hydroxide reacts with chlorine, then it produces bleaching powder CaOCl2 plus H2O. Let's see the next question. What happens when zinc granules are heated with sodium hydroxide solution? Write equation of the reaction. When zinc granules are heated with sodium hydroxide solution, then it forms a salt called sodium zincate, Na2ZnO2 plus hydrogen gas is liberated. What happens when bases reacts with non-metal oxides? Explain with examples. When bases reacts with non-metal oxides, then it produces salt plus water. For example, when calcium hydroxide reacts with non-metal oxide called carbon dioxide, then it produces calcium carbonate, a salt, and water. Let's see the reaction. When calcium hydroxide, a base, reacts with non-metal oxide called carbon dioxide, then it produces salt plus water, calcium carbonate plus water. What does this reaction tell us about the nature of non-metal oxides? Here the nature of non-metal oxide carbon dioxide is acidic in nature, because acid reacts with base to produce salt plus water. Thus non-metal oxides are acidic in nature. Whereas metal oxides are basic in nature. What effect does the concentration of hydrogen ion have on nature of solution? When the concentration of hydrogen ion increases in a solution, then the solution becomes more acidic. What effect does the concentration of hydroxide ion have on nature of solution? When the concentration of hydroxide ion increases in a solution, then the solution becomes more basic or alkaline. One of the following is a medicine for indigestion: sodium hydroxide, manganese hydroxide, magnesium hydroxide, and potassium hydroxide. Magnesium hydroxide is used as medicine for indigestion. It is also known as milk of magnesia. When magnesium hydroxide reacts with excess hydrochloric acid produced in stomach, then it neutralizes the acid by producing salt, magnesium chloride plus water. Hydrochloric acid reacts with metal X to form a gas Y, which burns with a pop sound. Sodium hydroxide solution also reacts with metal X and produces the same gas Y. Name X and Y. So X will be metal zinc, because zinc granules only reacts with acid as well as it reacts with base to produce a gas called Y. Y is hydrogen gas. So zinc granules reacts with hydrochloric acid to produce hydrogen gas, and similar zinc granules also reacts with base to produce hydrogen gas. Let's see the reaction. When zinc granules reacts with hydrochloric acid, then it produces salt zinc chloride plus hydrogen gas. Again, when zinc granules reacts with sodium hydroxide, it also produces a salt called sodium zincate, Na2ZnO2 plus hydrogen gas. Thus, X will be metal zinc and Y will be hydrogen gas. Write chemical equations of reactions of metal X with hydrochloric acid and with sodium hydroxide. I have shown you the reaction here. Here in this salt sodium zincate, the metal zinc is present as a negative ion. In my next video, we will study about the strength of bases and acids in solution or pH scale and the uses of pH in our everyday life. Thank you for watching my video, and if you find my video useful, please do like and share my videos and subscribe my channel to get the latest update of my videos. And if you have any doubt regarding this topic, comment below. I will try to answer as early as possible.